All right, down to the last section in this lesson. Questions 6 and 7. The number of people who receive the video link at each stage form a geometric sequence. A geometric sequence is a sequence of values in which a non-zero constant ratio exists between consecutive terms. The constant ratio is called the common ratio and is typically denoted by the letter R. The common ratio is the value that each term is multiplied to get to the next term. Write the numbers of people who have received the video as a sequence. Now we're going to go back to this chart over here. We want to write it as a sequence. Remember, that means we write 1, comma, 3, comma, 9, comma, 27, comma, dot, 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 to represent that this continues on. What is the common ratio? And justify your response. Now remember, it's the number that we multiply to get from one term to the next. The common ratio is 3. You multiply 3 to each term to go from one to the next. All right. 7. Identify each sequence as arithmetic, geometric, or neither. If it's arithmetic, state the common difference. If it's geometric, state the common ratio. All right. It says off to the side, an arithmetic sequence is a sequence in which the difference between consecutive terms is constant. The difference is called the common difference. So, I'm going to make a little note over here. Arithmetic, we either add or subtract each time. Geometric, we're either multiplying or possibly dividing. Okay? And neither, there would be no common difference or constant ratio. Okay, let's take a look at A. A goes 5, 8, 11, 14. The easiest way to do this is to take your calculator. And what I would start doing is I would start by doing 8 divided by 5. Well, that's 1.6. Let's see if we do 11 divided by the previous number. That's not 1.6. If it was a constant ratio, it would be the same number each time. Let's see if we can subtract and get the same number each time. To go from 8 back to 5, we obviously added 3. To go from 11, that's a 3. 14 minus 11 is 3. So, we would say that this is arithmetic, and our difference is plus 3. All right. We have 18, 6, 2, 2/3. Well, if I would have subtracted 18 minus 6, 18 minus 6 is 12, but 6 minus 2 is not 12. Okay, so that doesn't work. Let's do 18 divided by 6. That's 3. 6 divided by 2. That's 3. 2 divided by 2/3. That's 3. I got the same number repeating. So that means because we're doing division, this is geometric. What number do I multiply to go from 18 to 6? I know that if I want to go from 6 to 18, I multiply by 3, right? So that means to go the other way, I'm dividing by 3 or multiplying by the fraction 1/3. To go from 1 to 4, that's a plus 3. To go from 4 to 9, that's plus 5. And to go from 9 to 16, that's plus 7. So that's not arithmetic. To go from 1 to 4, you'd multiply by 4. To go from 4 to 9, you would multiply by 9 over 4. That's not the same. So that means that this is a neither. You can't add the same number, nor can you multiply the same number each time. All right, -1 to 4. I either add 5 or multiply by -4, right? So either add 5 or multiply by -4. Well, if I added 5 again, does that get me to -16? No. So that doesn't help. What if I go times -4? 4 times -4 is -16. -16 times -4 is positive 64. So that makes this geometric. And we are multiplying by a -4. Make sure you put that negative because it is changing signs. All right. And E. We go from 16 to -8. Well, we could subtract 24, right? But to go from -8 to +4, you don't subtract subtract 24. So that doesn't work. To go from 16 to 8, you could divide by -2. Well, is -8 divided by -2 a +4? Yes. Is +4 divided by -2 -2? Yes. So this would be geometric. And because it's actually dividing, we're multiplying by the fraction of it. So 1/2. And it would be negative. On to the last part of our wrap up here.